Based on the frequency, the sound has been classified into three types. One is infrasonic, audible, and ultrasonic. Infrasonic, less than 20 hertz of frequency, infrasonic. 20 hertz to 20,000 hertz, audible, and above 20,000 hertz, ultrasonic. Okay. So do not be in a confusion that the high frequency like 21,000 hertz is of a very high loudness. Not like that. Okay. So pitch is high, but not the loudness. Okay. Some of the animals, I'll show you. So some of the animals, dogs, can hear as high as 40,000 hertz. The dogs can hear infrasonic, audible, and ultrasonic also. Cats can hear 100 hertz to 60,000 hertz. So it can hear audible and ultrasonic only, not infrasonic. Elephants 1 hertz to 20,000 hertz, audible as well as infrasonic. Grasshoppers 50,000 hertz, audible, infrasonic, ultrasonic. Mice 1000 hertz to 1 lakh hertz, audible, ultrasonic, it can hear. Dolphins up to 1 lakh hertz, moths 1000 hertz to 2,40,000 hertz. That is what here it is given, but in your science booster it is given very clearly like tabular format, that it will be easy. And there is something called hearing aids. If there is any defect in the eye, we use optical aids. If there is any defect in the ear, listening, then hearing aids. People with hearing loss may need a hearing aid. A hearing aid is an electronic battery operated device. Okay. The hearing aid receives sound through a microphone, and the microphone converts the sound waves to electrical signals. These electrical signals are amplified by an amplifier. The amplified electrical signals are given to a speaker of the hearing aid. Then the speaker converts the amplified electrical signal to sound and sends the ear for clear hearing. So it is basically the conversion of energy is taking place. Okay. So the hearing aid amplifies the signal. That is very important. So the hearing aid, the output of hearing aid is amplified signal. So we can hear very clearly. So what is the audible range? 20 hertz to 20,000 hertz. What is the range of frequencies associated with the infrasound? Less than 20 hertz. Ultrasound greater than 20,000 hertz. Next, applications of ultrasound. Okay. If we talk applications, ultrasounds are of high frequency waves. Ultrasounds are able to travel along well-defined paths even in the presence of obstacles. Okay. Even in the presence of obstacles. Ultrasounds are used extensively in industries and for medical purposes also. Okay. Actually, last year Sampuran has given the presentation on this about ultrasounds and its application in nanotechnology. Ultrasound is generally used to clean parts located in hard to reach places. Okay. Inside like small cylindrical bolts are there or nuts are there, some pipe shaped cylindrical uh, tools are there, then okay, then we can clean it with the ultrasonic waves. Just you have to take some water in the ultrasonic chamber and you just make it to, well, like send the keep the clean keep the parts to be cleaned in the water which is in the ultrasonic chamber filled with water, then send ultrasonic waves. Due to its high frequency, it will go, water waves will go with a high energy and it will cleans the parts. Okay. That is one of the application. Ultrasound is generally used to clean the parts located in hard to reach places. We cannot keep our hand or our finger, so in such places we can use ultrasounds. For example, spiral tube, odd shaped parts, electronic components, etc. Okay, objects to be cleaned are placed in a cleaning solution and ultrasonic waves are sent into the solution. Okay, that's what. And due to high frequency, the particles of dust, grease, or dirt get detached and drop out. Okay, and the objects thus get thoroughly cleaned. And one more application, like ultrasounds can be used to detect cracks also. It can be used to detect cracks in the metal block. See here, if there is a crack here, if you send the ultrasound waves, no? There are detectors here. Here left side ultrasonic sound source and right side detectors, ultrasound detectors. Okay, and if you are keep on sending the ultrasonic waves to the metal, whenever there is a crack, wherever there is a crack, and the waves are reflected back, and here detector will not detect those waves, so we can understand that here is a crack. So to detect the cracks in the metals, we use ultrasounds. Okay. So first application is to clean the parts. Second application is to check the cracks present in the metal. Okay. And third application, I think, third application in the medical purpose. Like ordinary sound of longer wavelengths cannot be used for such purpose, as it will be bending around the corners of the defective location and enter the detector. Okay, so ordinary waves, if you send, no, ordinary sound waves, then it may bend because it is having less energy. It bends and it may reach the detector. But if you send ultrasonic waves, it will not bend and it will not reach the detector. It simply reflects back at the crack. So the next ultrasonic waves are made of from various parts of the heart and from the image of the heart, and this technique is called echocardiography. Okay, echocardiography. That reflected sound waves, you will send the sound waves, ultrasonic waves, onto the heart, and some of the waves gets reflected back, and that by capturing the reflected ultrasonic waves results a image. So there are some particular equipments they use to form the image by capturing the reflected ultrasonic waves. Okay, so that we can understand the like for example, if there is any hole in the heart, or if there is any stone in the kidneys. Okay, so this is in this way it is used in the medical purpose, and it is also used for the growth. The doctor may image the patient's organs such as the liver, gallbladder, uterus, kidney. Okay, all those. If you want to image the gallbladder, uterus, or kidneys, liver, then the doctor will suggest you for ultrasonography. Okay, based on the image that we get from the ultrasonography, he will give some particular medicine, or he may also suggest you for surgery. So there are many actually gallbladder stones. There are tumors, and then the stones in the kidneys also can be detected. Abnormalities in the liver function, that also can be detected. So in this way, the medical purpose is used, and for the pregnant woman also, in order to understand the growth of the baby, they use ultrasonography. To check the baby growth in a uterus, we have to go for, they suggest every month ultrasonography doctor. And ultrasound may be employed to break small stones also. Ultrasound may be employed to break small stones. With this kind of energy, if you send the ultrasound energy onto the particular stone in the kidneys, if it is a small in size, it can also break, and after breaking the stone, you can drink some water, and having a sufficient water may like it may remove the small stones also. Okay, these grains later get flushed out with urine. Okay, these small stones can be made into pieces, small grains, and that small grains can be flushed out with urine. Okay, can be flushed out with urine by taking a proper uh, water levels. You have to take some proper water levels. Then you can flush out the stones. So these are some of the applications of ultrasound. So what we understood, the summary is there are different types of frequencies of sound: infrasonic, audible, ultrasonic. Less than 20 Hz infrasonic, 20 Hz to 20,000 Hz audible, greater than 20,000 Hz ultrasonic sounds. And some of the applications of ultrasonic we have understood, like they can be used to clean the things, they can be used to detect the cracks which are present in the metal blocks, and they are also used in medical purpose, like in echocardiography, and to detect the stones in kidneys, gallbladders, okay, and to detect abnormalities in the liver, okay. Also, some of the stones can be broken into pieces with this ultrasound energy.